All right, this is June 2017, parts 2, 3, 4, Algebra 1 Regents. This is expressed in simplest form. So here we're going to have to show our work. And I know it's not as easy as doing the multiple choice, but I'm going to try and do the steps for this process as clearly as possible. First, I want you to realize that the first set of parentheses have no exponent other than 1, and there's nothing out front. So these parentheses are irrelevant. I can drop them. However, this minus in front of these parentheses means we're minusing all of these terms, which means each of the terms gets a minus. If it already had a negative in front of it, it now becomes a positive. If it didn't, it now becomes a negative. At this point, it's just a matter of combining like terms. I have 3x squareds and 2x squareds for a total of 5x squareds. I have a positive 4x and a negative 4x, and they cancel. And a negative 8 with a negative 2 makes a negative 10. Down here, graph the function. My biggest piece of advice for graphing any function, especially if it's squared, and I know that a squared is a quadratic, which means it bends like a U, so there's a turning point, and that's going to be really important. I want you to include a table of values. Go to my calculator. I'm going to type in x squared, negative x squared, minus 6x. I'm going to go right to my table. Hold on here. Give me a second. I'm going to go to my table until I start to see some numbers repeat. And actually where I am right now, I see that happening. I don't know if you can zoom in, but there is a 9 stuffed between some other numbers that match. That 9 doesn't have a partner. Maybe I can bring it closer. Let's see, is that helping? Not helping at all. Okay. But this 9 right there in the middle doesn't have a partner, but all the numbers around it do. So I feel like that's significant since I'm looking for a turning point, and that's the one point that doesn't match. So I know that negative 16 is too big to put on this graph, so I'm going to start at the negative 7, negative 6, negative 5, negative 4, negative 3, negative 2, negative 1, 0, 1, 2. And I'm going to write down negative 7, 0, 5, 8, 9, 8, 5, 0, negative 7. And I'm going to, oops, I should have stopped at 1. I'm going to graph these points. Some of us have found a lot of success. Change the light here. Some of us have found a lot of success by labeling the x-axis. So we might as well keep doing that. I don't have all of these positive numbers out here, so I'm only going to label to the ones that I actually have for sake of time. Alright, at negative 7, I go down 7. 1, 2, 3, 4, 5, 6, 7. At negative 6, I go to 0. At negative 5, I go up 5. At negative 4, I go up to 8, and then to 9, and then to 8, and then to 5, and then to 0, and then finally to negative 7 again. When you get comfortable with graphing quadratics, then that pattern is going to make a lot more sense. But for right now, that's what it is. Soft curve when you're connecting. You don't want straight segments. And it says state the coordinates of the vertex. The vertex is the turning point. Okay, it's the one point that doesn't have a match on either side. It's found at negative 3, positive 9, And I know that on my table because it's the one that looks different in the y values than all of the others. Okay. State whether 7 minus radical 2 is rational or irrational. If you throw this in the calculator, it's going to look like an ugly decimal. And the reason is because it is irrational, since adding with irrationals stays irrational. There's a better way to say that, but for right now, that's good enough. V of t, we're given a formula. It says state the purchase price of the car. State the percent that the value of the car decreases. Okay, so I mentioned in a previous lesson that interest formulas were of the form p times 1 plus or minus r to the t. I think I might have put plus only, but it is plus or minus. Now if you look at the two different problems here, we're saying that that middle portion is equal to 0.85. 1 is like 100, and 0.85 is kind of like 85. So what did I do to get from 1 to 0.85? And I ended up subtracting 0.15 to do it. Okay, you could just write 1 plus r if you want, and then subtract 1 from both sides, and you end up with 0.85 minus 1, you end up with this. So what does this mean? This means that it went down 15%. Okay? 15%, because 15% is like 15 cents when it's written as a decimal. It's a good way to compare the two. All right, survey of 100 students was taken. It was found that 60 students watched sports. 60 students watched sports. That's a total. 34 students did not like pop music. I also know there were 100 students, so I know that corner. Of the students who did not watch sports, the ones who did not watch sports, well, before we even do that, if 60 did, then how many didn't? Oh, 100 minus 60, notice I'm showing my work, is 40. So of the ones that didn't watch sports, 70% liked pop music. 70% of 40 is a multiplication problem. Throw that into the calculator. 0.70 times 40 is 28. 28 did not like pop music. Of the students who did not, liked pop music. Complete the two-way frequency table. All right, so a couple things to keep in mind. This is supposed to add to 40. So that means the missing piece is 12. Okay, well, what plus 12 is 34? 34 minus 12 is 22. All right, then 60 minus 22 gives me the missing piece, 38. And then if I'm finding a total, I add these two together. 38 and 28 is 64. Okay, so all the lines across should equal 38 plus 28, 64, 22, 12, 34, 60, 40, 100, and all the lines down should equal 38, 22, 60, 28 plus 12, 40, and these add to 100. Okay. Graph the inequality. Again, please use a set of an XY table. Sorry. You can't do that until the 4 is on the other side, though. So I'm going to subtract 4. Don't put it in the parentheses. Just leave it as y less than -2 parenthesis x minus 4 minus 4. Don't do anything else with it. -2 x minus 4 minus 4. Look at the table. 20 is too big, so I'm going to start at -3 where it's mapped to 10. And it really doesn't take long before you see a pattern. If you see the pattern and it's linear, meaning that it's the same number every time, then you can stop and just copy that pattern, complete that pattern overall. Negative 3, I've got 10. Negative 2, I've got 8. Oh wait, 2, 4, 6, 8. So this is not 10. Then 6, then 4, then 2, then you know it's going to be 0, negative 2, negative 4, and negative 6, negative 8. Again, you can, I'm sure I counted that right. You can use the table for anything that'll fit on that graph. A couple things to keep in mind: inequality graphs are not necessarily straight equations. This one does not have the equal sign, so it's going to be dotted. And then I also spoke in a previous lesson that you pick a number to see if it works. So I'm picking 0, 0. If I take 0 and I store it into x, and 0 and store it into y, and then I type my inequality, which originally was y plus 4 less than negative 2 times x minus 4. It works. There's a 1 there. Whoops. Let's go back to. See, there's a 1 there. I can't see. There's a 1, which means it works. That means that it's on the side of all of them that work. One point is not going to work. The whole side is going to work. All right, determine, or if f of x equals x squared and g of x equals x, determine the values that satisfy where they're equal. Okay, keep in mind, this has f of x and g of x, so they're only concerned with x's. They don't want y's. There's no y written here. So I'm going to graph x squared, and I'm going to graph x. And the graphs look like this, and this is just a sketch, nothing fancy. Okay, now where do they cross? It looks like the blue graph goes underneath the red for a little bit, so I'm going to use my table just to be sure. I want to see where I have similar values. Okay, if you look carefully, you see some matching zeros and some matching ones. At 0, they're all 0. And at 1, they're all 1s. So this means that at the point 0, 0 and 1, 1, they're the same. But again, they don't want the y values, they want just the x values. So x is 0 and 1. Moving on, describe the effect of each transformation. All right, if you do a minus on the inside, parentheses and also absolute values lie. So this is a horizontal translation, but it's not going to act as though it's negative. It's going to be moving to the right a units. This one's on the outside, so this isn't up and down, and it's not inside the symbol, so it's doing exactly what it's saying it's doing. This one is down. Moving on. It's defined by this function, use factoring. Okay, in order to do factoring with the limited time that we have, my best suggestion to you is to figure out the zeros of this function. Okay, if I go into y equals and I type in x squared plus 3x minus 18, and I want to know on the graph where I actually hit the x-axis. I hit at negative 1, 2, 3, 4, 5, 6, and at positive 3. Factoring looks like this. Take the opposite and plug it in. Take the opposite and plug it in. The zeros represent the roots. Okay. Based on the graph, during which interval did Craig most likely drive in the city? Okay, well here he's driving. I'm going to look for the slope. Up 30 over 1, meaning I'm in order to go 1, I have to go up to 60 and over 1. So this is 60 miles per hour. This one is 110. Well, let's see, 0. We're not traveling any miles. This one I'm going up in 1 hour span. Let's see, here's the 4 hour, and here's the 5 hour. So I've gone up from 40 to 200, which is 60. Okay, and then here, at the 5 hour mark to the 7 hour mark, I've gone up from 200 to 240, which means I've gone 40 miles in 2 hours, or 20 miles per hour. Based on the interval he's in the city, most likely from D to E, because the slope is 20, and that stands for miles per hour. Explain what might have happened between B and C. Well, if he's driving the highway and he stopped for a full hour and a half, he probably was eating. Okay, he probably stopped somewhere to get something. And his average speed to the nearest tenth of an hour for the entire trip, well, he started at 0, but his total miles were 230. And it took him 7 hours to do that. 230 divided by 7 is 32 and some change. So it says to the nearest tenth, that'd be 32.9 miles per hour. Okay, moving on. 35, given the equation, algebraically to the nearest tenth. Okay, so g of x is equal to 2 times k of x. I want to get everything to one side. This is going to be 2x squared. If I subtract 4x from both sides, I get negative x. And if I subtract 32 from both sides, I get negative 22. And there's this thing called the quadratic formula. You let a equal the coefficient of the first term, b equal the coefficient of the second term, and c equal the coefficient of the third term. And the quadratic formula is given. You can look it up in your book. It's negative b plus or minus the square root of b squared minus 4ac all over 2a. And all you have to do is store those numbers in the calculator. All right, so 2 stored into letter A, negative 1 stored into letter B, and negative 22 stored into letter C. It's equal to negative b plus or minus, I can't do both at the same time, the square root of b squared minus 4ac, whoops, it's supposed to be inside. Over 2a. One of my answers is 3.5 and some change. If I do it again and put a minus, then I get x equaling approximately 3.6 and negative 3.1. Okay, since there's no y's up here, then I don't want y's in my answer, I just want the x values. Explain why you chose this method. Because the quadratic formula always works, especially with irrationals. Irrationals are those decimals that go on forever, don't stop, don't repeat, like the answers that we have here. Last one of the part 3s. Michael has $10 in his savings account. Option 1 will add 100 to his account each week. Each implies a slope. 2 will double the amount at the end of each week. Write a function in terms of x to model each saving. So we've got option 1, which is write a function. It doesn't say function notation, but I'm still going to do that. F of x equals $10 plus 100 every week. The other function will double the amount in his account at the end of each week. Okay? This is the formula for doubling. I would explain that more in detail. It's a chapter that we'll probably get to, hopefully, when we get back. Michael wants to have at least $700 in his account at the end of 7 weeks to buy a mountain bike. Determine which option will enable him to reach his goal. All right, if I plug in 7, which ones will allow me to have $700? Well, this one comes out to be 710. And this one comes out to be $12.80. So both are greater than 700. Now, one might be better than the other. For example, you might want to do this option because then he'll have some extra money left over, whereas over here he doesn't really have that. But both of them are above the 700 that he needs. Okay. Justify your answer. I'm just going to write if they're both greater than 700. All right, last question. Central High School has 5 members on the swim team. Over the next several years, the team increased by an average of 10 members per year. Slope. The same school had 35 members in their chorus. The chorus saw an increase of 5 members per year. Slope. System of equations, where x represents number of years. Okay. So for the first equation, we start with 5, and then we increase by 10 per year. The second equation, we started with 35, and we increased by 5 per year. It says graph the system. This is written so that the origin is right here. So I'm going to make sure that I have 35. I don't have 35 boxes to start with. There's probably 20 here. So I'm going to let each box equal 2, which means that this would go up to 40. 35 would be 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 35. And 5 would be 2, 4, 5. Okay. 6, 8, 10. I'm going to label my 10s. 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. 4, 6, 8, 10. I have no problem with my 1s being across the bottom here. So let's see. Graph the system. So each week, if I don't remember since 2010. Since there's only been 10 years since 2010, this would have only been 7 years since 2010. And I know I have 20 boxes here. I'm going to let each box equal 2. Or each year be 2 boxes. Again, there's a reason why, and that's because I don't care about going past 2020 or 2017 the year of the exam. Alright, if I use my first one and I go up 10 every time, okay, if I start at 5, then the next one's going to be at 15. And 2 is going to be at 25. And 3 is going to be at 35. And 4 is going to be at 45. Okay, so it's going to look like this. Please use a ruler. That's Y1. This one goes up 5, so if I'm at 35 now, then after 1 week, I'm going to be at 40. Okay, not the best picture because you can't see where they cross, and that's my fault, but whatever. Explain in detail what each coordinate of the point of intersection means. It doesn't say find the system, but we're going to anyway. So on an actual graph, and I apologize for this, I probably should have let each one be much more than 2. I've got 35 plus 10x, and I've got 5 plus 10. Nope. 5 plus 10x. 35 plus 5x. They're not going to cross here. Where they're going to cross, let's see. I'm going to start my x min and my y min at 0. See if I can see the graph anywhere. Okay, I see one graph. It needs to be much higher. So maybe my window should go as high as 100. Alright, there's the blue graph. And there's the red graph. If you ever want to find the point of intersection, I'm going to draw this off to the side. If you ever want to find a point of intersection, all you have to do is press second, trace 5. Second trace 5. Second trace brings you to this calculate button, and 5 is the word intercept. All you need to do is get your cursor close to the point of intersection and press enter. If it's there again, press enter. You'll see that it says second curve. Then it says guess, because they want you to be really sure, so press enter one more time, and then it'll finally tell you the point of intersection, which is the point 665. So the detail of this coordinate is the fact that it's 6 along here and 65 along here. 6 was the number of years since 2010, so that would be 2016. In 2016, both groups have 65 members. Okay, I apologize for this graph. It was crappy, but it still would have counted. All right, June 2017, part 234.